Okay, so this is 99 bottles. Last week we left off on section 5.2. That's where we'll continue this week. So...
Sorry, Nick, your voice is low again. I think it's you.
It's probably me. I'm not awake. We'll try
No, your volume.
louder.
I mean, your volume went down. It's going to
My
be back
volume?
bad in the
Is
recording. No.
It's not me then. It's just the mic. Hey, Stola.
Hey.
Can you hear me all right?
Yeah, but your voice is low.
Oh boy. How is this?
Still low.
Yeah? Oh man. Sucks. I think I've been starting to have problems with this microphone.
But we can hear you.
Should be a way to change the volume on StreamYard, but I can only mute and unmute.
Now see, it seems better.
Seems better?
Yes. This is okay.
Okay. Let's get started then. So yeah, so let's see. So we're in 5.2. Well, let's go over 5.1 real quick. There's not much to it. So I think we stopped here, no? Maybe it was 5.2. I don't know. So anyways, okay, so we're all done with the first 4 chapters. So just as a reminder, this is code looks like. We've got 3 public methods. We've got song, which returns a song. We've got verses, which returns a range of verses. We've got the verse method, which returns a single verse. And we've refactored the verse method out into one simple template. And then we've got these 3, 4, 5 private methods: quantity, container, action, pronoun, and successor. And if at any time you have questions on why we did what with what, just speak up. So just as a recap, the previous 2 chapters applied the flocking rules to reduce duplication in the verse method. So now we want to implement the 6-pack, feature. So whenever we sing 6 bottles of beer on the wall, 6 bottles of beer. So whenever we say 6 bottles, we want to say 6-pack instead. So can we implement that feature now without modifying the code? Can we implement it? Is this code, basically, is this open for extension? Can we extend this code and implement the 6-pack feature? So is it open? So this is our chart that we're going to ask for, right? Is it open? So honestly, this code is not open yet. So do you know how to make it open? It's not clear how to make it open, so we continue. We keep removing code smells, right? So yeah, so despite the fact that you've successfully replaced a fair amount of duplication with well-named methods that expose concepts in the 99 bottles domain, the resulting code is not yet open to the 6-pack requirement. And if anything, the current incarnation is less amenable to this requirement than was Shameless Green. So it's even harder to make the change now after our refactoring, but it will get easier if we keep going. The refactoring we've done so far is good. We're going in the right direction. So 5.1.1 talks about identifying patterns in code. We look at our private methods. We can see a very obvious pattern here. Each method is the same length. They all have an if, else, and end statement. They look awfully similar. They all take number as an argument, and they all test number to be equal to some other number. So yeah, so basically any methods have the same shape, take the same argument. We went over this last week, so I'm not going to go in detail. Spotting common qualities. So do any methods have the same shape? Yes, the flocked 5 all have the same shape. The flocked 5 is the 5 private methods. And you can perform the squint test to see that, right? And squint test is basically, if we zoom out, you can kind of see that, oh yes, they do all have the same shape there. Right. The flocked 5 all take the same argument, and plus verse takes the same argument too. They'll take a number, so these 6 methods. Do arguments of the same name always mean the same thing? No, they don't mean the same thing. Verse means a verse number, whereas the flocked 5 actually mean a bottle number. Yeah. And then if you were to add the private keyword, where would it go? We already added the private keyword, and it would go right above the flocked 5. This is our public API here, these 3 methods. And then if you were going to break this class into 2 pieces, where's the dividing line? It would be right here, right where the private keyword is. This would be the dividing line. This would be one class, and this could be another class. So enumerating flocked method commonalities. Do the tested and conditionals have anything in common? Yes, they all seem to have something in common. And the code above, not only do all the conditionals test the value of number, but they test for number to be exactly equal to another number. And we talked about how testing for equality is better than testing for greater than or less than. If you can test for equality, test for equality.
I have a question on testing for equality.
Yeah, go ahead.
Between using the equal to sign and using terms like equal, is there a big difference?
Can you repeat the question?
When you're testing for equality, in some cases you might use the double assign operator, or you might use keywords like equal or EQL. Is there a much difference on that?
I think they both do the same thing under the hood. Right? If you send an equal method, it's basically does the same thing as the double, as the equal operator, the double equal sign.
And in terms of speed?
And that's dependent on the language that you use to. For instance, in Java, and correct me if I'm wrong, Ricardo, but if you use the equal method on a string, like they tell you to use the equal method when you're comparing strings in Java, because if you use the double equal sign, it's actually going to test something else. But it's language dependent, but ideally, ideally or under the hood, especially in Ruby, they both do the same thing. I think there is an equal method in Ruby, right? But under the hood, it does the same thing. I think this is actually just syntactic sugar. I could be wrong.
So Java always encourages you to use methods on objects when you're doing conversions because it doesn't trust you and it doesn't trust itself. Okay. It's actually, I think it's for everything because you never know the equals what it's actually going to do. Right. And yes, strings is equal. Otherwise, I think it's going to check the objects if they're the same object. Ruby encourages you to write readably, however you like. So it's usually, if you have, I think you can actually, that's a method. Yes, it is syntactic sugar because you can define equal in Ruby.
Exactly, yeah.
They do the same thing, but Ruby does it better as usual.
Yeah, the double equal sign in Ruby is just like sending a method. So there's no difference in Ruby. It depends on the language you use, but ideally it shouldn't matter. Does that answer your question? Or did we totally get the question wrong? Did I answer your question, Stella?
I was muted, sorry. Yes.
Cool. Hello, N. All right, let's continue. So how many branches do the conditionals have? Well, they each have 2 branches, truthy branch and a falsy branch. Do the methods contain any code other than the conditional? No, each method is named after a concept and contains a single conditional. This conditional uses a value of number to choose a correct concrete expression of the concept. Yeah, so there's no other, sorry. There's no any other code within the conditionals, right? They all return something explicit. Do methods that take number as an argument depend more on number or more on the class as a whole? That's a good question. They depend more on number, right? So yeah, the Flox5 depend only on the number argument rather than on the rest of the class. This is true even for action. If you accept that although action depends on pronoun, pronoun depends only on number. There you go. Yeah, so 5.1.4, insisting upon messages. So this code contains a deeply non-object oriented pattern. The Flox5 methods take an argument, examine it, and then supply behavior for it. So we take a look at this, right? So when we call a method container, we pass in the argument number, and then we're doing a test to determine what we should do. This is very non-object oriented. It's this. What's the other word? This is very like sequence. No, it's not. That's not the right word. This is very sequential coding, right? Do this, do that, do this, do this. Otherwise, do that or do that. ideally, in object-oriented program, we just want to send methods. Send messages. So what we should just do is something like this. When we call the method container, we can just call a method on whatever we pass into it, right? We're passing in a number. We should just be able to say, hey, number, what's your container? This is like a bottle number, right? So we can ask the bottle number, what's your container? So good. So we're at 5.2. So yeah, if we take a look at this, everywhere we pass a number here, it's different than the verse number. The verse number is an actual verse, actual number of a verse, but all these flocked 5 methods, they're actually a bottle number. So it'd be ideally if we could just tell the bottle number or ask the bottle number, what's your quantity? Ask the bottle number, what's your container, and so forth. So the questions above identify characteristics that group methods together, and many of these groups overlap. For example, a number of methods take the same argument. Most methods that do so have the same shape, contain a conditional, could be considered private, and depend more on the argument than on the class as a whole. Yeah, these methods depend more on this argument than on the rest of the class, right? Each item above acts like a vote, and these votes combine to point to primitive obsession as a dominant code smell. So built-in data classes like string, integer, array, and hash are example of primitives. Primitive obsession is when you use one of these data classes to represent a concept in your domain. Obsessing on a primitive results in code that passes built-in types around and supplies behavior for them. So here we're relying on number is an integer.
Nick, sorry, can you unmute again?
Yeah. Is that working?
No.
No. Yeah, I think it's my mic. Someone was telling me the other week that my mic was buzzing, which is the first time I've ever had any mic issues. I have to buy a new mic. Which sucks because I don't have any. I don't think I have any money for that.
Something you did made it work again. So try doing things in previous occurrences.
How's this?
No.
No. All right, I'll just try to speak louder. Is this better? No.
Well, I can hear you, just barely.
Oh man.
Well, no,
For me,
not choice, right?
Hearing him.
What's that, Stella?
I've been hearing you.
Oh, you can hear me fine?
Yeah.
Oh, no. So maybe this time it was me. Sorry. I heard Stella low as well at some point. Now I hear you both fine.
Oh, okay. Interesting. Cool. Well, let's keep going then. Yeah. So number is an integer, right? And integers are primitives in almost, I think, every programming language. And so we're obsessing on this primitive, right? We're asking this primitive, what are you? Are you a 0? Are you a 1? And then we're going to supply behavior depending on whether, what this primitive is, this integer is. And that's primitive obsession. We're obsessing about this primitive. We need to know what this primitive what this integer is before we can do something with our application. So the cure for primitive obsession is to create a new class to use in place of the primitive. For this operation, the refactoring recipe is extract class. So let's get to it. So having decided to cure the primitive obsession code smell with the extract class refactoring, you must now choose a name for this new class. Basically, I'm not going to read all of this, but basically when we're talking about naming methods and stuff, I always said to try to name the method one abstraction higher. Right? So instead of, so for example, when we came up with the container name, we didn't call it bottle, right? One abstraction higher, container. And that works for methods. That's great for methods. And you can read this later. It's pretty good. But basically for classes, when you want to name a class, it's best to just name it what it is. Instead of naming it an abstraction higher, you should just name a class what it actually is. And so come up with bottle number, because we are number, this number that's being passed around all these methods here. It's a bottle number, right? So we name the class. The new class is going to be named bottle number. So this section here, we'll extract a new class named bottle number. Did I start up VS Code? I did. So let's start collaboration session. All right. If you want to log in, go for it. All right, so this section extracts a new class named bottle number from the existing code. And it does not use TDD. Instead, it creates a new class by following a slightly modified version of Martin Fowler's extract class refactoring recipe. We already have tests in place too, so we'll be depending on those tests. And if you bought the new version of 99 bottles, it actually continues. It's got 3 extra chapters, and it goes back and writes unit tests for this new class. So, so maybe I should read this. It's been a while since I've done this. So as you might recall, safe refactoring relies upon tests running green. So the fact that the new bottle number class will come into existence before its tests arrive has a couple of consequences. First, the existing bottles tests become the safety net for this new class. They were originally written as unit tests, but using them to indirectly test bottle number transform them into a kind of integration test. So these tests must continue to run after every change. Next, while extracting the class, code that is known to work is copied from bottles into bottle number. So it's important to put this new class fully into use before editing any of the copied code. Safety is being provided by the bottles tests, so they must exercise the new code as quickly as possible. So yeah, so in the previous chapters, we would parse the new code, parse and execute it, parse, execute, and use its result, and then delete unused code. And we'll still keep doing these steps. So let's get to it. We're going to create new bottle number, and we're basically going to copy all the flock5 methods into bottle number. And then we can start calling them from our bottles class. We can start calling them from the bottles class, run the test, make sure they're all working, and then we can start refactoring the new class. So let's get to it. All right, so you're logged in. So I need to create a new file here. Let's see, so I got create a new file here. We'll call this bottlesnumber.rb. Let me make sure the guard file is going to run this. So what I would like to do is when we have any change, I just want to run my test suite. What's my bottles test? So I'm just going to say run bottles test here. All right, so then hopefully anytime we make a change, it'll just run all the test. I'll start that in a new terminal. Okay, so I'm gonna exit guard. All the tests are failing. Somebody make changes already. What's going on? Why did it fail? So these were all passing last week, right?
Oh, yeah. What's the error message from the tests?
It's output. The output's wrong. Well, it looks like we deleted pronoun. No? Oh, maybe not. Just moved it. This seems about right. So I think it's like an end of line is missing. Oh, we're missing one. Take one down and pass it around.
That's pronoun, right?
Yeah.
Or, yeah.
We don't have pronoun in our verse method anymore. Looks like it got deleted somewhere. So action. So what? So action takes pronoun, right?
Yeah.
Yeah. Action calls pronoun. Oh no, action calls pronoun right there. Take. That's weird. So it should be returning. But it's not getting anything back. Getting empty string back. And run the test again. Yeah. 6 failures.
Try. Did he try saving?
Yeah, I just saved it before I ran it.
Then maybe the tests are running in a different place. Are you in the right directory?
Yeah, I only have one.
Okay.
Pretty sure. I can run the test here. Yeah, I mean, it's the same one. Yeah, it's failing there too.
It's really strange.
Yep. Now it's getting it. Now the tests are passing. Okay.
So not sure if that is the issue, but on line 45, it was else if and there was no condition. So I returned it to else.
Oh, okay. Okay. Thanks for catching that. I better commit this. Let me go get add dot status git commit ch5.2. All right. So tests are passing. Okay, so we got our new bottle number file. So who wants to go first?
What's the next thing? What's the next thing? Are we just extracting bottle number?
Yeah, we're going to do the extract class. So we'll first create class bottle number.
Okay, I can go then if nobody else wants to.
Yeah, go for it.
Nick, could you please restart the terminal? I don't have access to the terminal.
What? Say that again.
Please restart the terminal. Just the terminal, not the text editor.
Restart the terminal.
Yeah.
What for?
I didn't have access.
I got the terminal running right here.
from
Test our
the
passing.
VS Code side. From the VS Code side.
I'm just going to keep it closed. We don't need it. We don't need it open.
Okay.
Yeah, the test will run every time we save the file. The test will run automatically. So I don't.
Oh, that's cool.
It'll just be in the background. All right. So line 1, let's create class bottle number.
Oh.
At the end statement.
At the beginning. Okay. I will.
Where are you, Ricardo? Oh, you're doing it in here?
I was hearing you type in the
sorry. I actually didn't notice you created a new file. Yeah.
Yeah, created a new file.
I wasn't following you. Okay.
It's all right.
So, can you? Do you want to check out bottle survey?
Cool. And so let me save. So I see changes. So it looks like changes got made again to this file. It shouldn't be.
Yeah, because yeah, still that was my change, my mistake. I would recommend you check out the file so we're sure.
All right.
Line 45 is back to how it was. I don't know why.
It was. It is. So that's the problem. Somebody keeps typing else if.
I undid too many times, I think.
All right. Okay. So tests are passing. Yeah, so what we'll do is we'll copy the flocked 5 and put them in the bottle number file.
Yep. If I split like this, can you see it? That's a no, right?
Yeah.
Okay. So first, the flock file is back into bottle number, right?
Yep. So I'll save. So yep. Okay. So the tests are passing. Let me. So yeah. So we haven't really done anything yet. All right. We just copied those methods into the new class. We're going to do require relative up here on line 1. Bottles. Oh, I named it bottles number. Oh well. Now let me change it real quick. Should be bottle number. I guess I can probably do that here, right? Rename bottle number. Okay. So yeah, so now let's just check the book. But I'm pretty sure I know what to do next, but let's check the book. Okay, so yeah, so we copied that into bottle number. So the bottle number class needs to know the value of number. So we're going to add an attribute reader for number and an initialize method to set the variable. So here's the code. So Stella, do you want to do this for us?
Yeah.
Cool.
It's bottle number. Is the attribute reader bottle number?
Just number should be fine.
Okay.
Yeah.
Nick?
Yeah, number is fine.
Okay.
Cool. So we'll save it.
Oh, it's not automatically saved.
No, I don't have it set up like that. So I saved it. Tests are passing, so there's no syntax errors. So far, so good. So we're not actually hitting the file yet. So this talks about, I'm sure you already know this, but so on line 2 here, the attribute reader is a class method. Invoking it with the symbol number effectively defines a new instance method on bottle number. It basically does this, right? So because of the attribute reader, bottle number responds to the number message by returning the value held in the @number instance variable. Yeah, you know all that. So okay, so the bottle number class now contains all of the necessary code, but as yet this code is only being parsed. So the next small step is to execute a bit of the new class without using the results. The following example does this by altering the container method of bottles to invoke the container method of bottle number. So here in the container method, we're going to create a new bottle number and pass it container.number. So we execute the code, but we don't use the results yet, right? We're still relying on what's returned in container. So we'll do these small steps. And it's almost 10 or hours almost up. So yeah, we'll get through this one method. So yeah, Ricardo, do you want to do that on the container method?
Okay. Then yeah.
All right. Test passing. So yeah, so now it talks about this code is pretty ugly, right? We're instantiating bottle number and then calling container. We're passing number twice. Ideally, it should look like this: bottle number.new number.container. But we're going to refrain from making this change just yet. So setting the unpleasant code temporarily aside, the next small step in the current refactoring is to use the result of the container message. And we can simply do that by moving bottle number from where it is down to the end of the conditional.
Move it. Okay.
Yeah.
Keeps the code anyway. Okay.
And save it. All right, passing. So the next small step would be to remove the unused code. So now we can remove the unused code and save it.
Yeah. Is it not saving when I tell him to?
When you hit save on your end, it doesn't save on my end. So I still need to hit save.
Yeah.
Is this a VS Code thing?
I don't know. I didn't think it was like that, but I noticed it started doing that. Maybe it got changed.
Must be a feature.
Yeah. All right, so repeat the above procedure for each of the methods. So yeah, so let's do that real quick. So we can, Let's Stella, do you want to do it for quantity?
Yep.
All right.
Wait, where is that file? Oh, okay, got it. What are we changing in bottle number or in bottle?
In bottles.
Oh, okay. Then quantity, okay. Yeah. Done.
You're done?
Mm-hmm. We change everywhere.
Tests are failing. So when tests fail, let's undo what you just did.
Okay.
All right. So what we want to do on quantity is we want to call bottle number dot new number. Then we want to pass it the quantity method.
All right.
If we have to.
Okay.
All right. Then yeah, let's finish this up. Stella, why don't you take action? Ricardo, you take pronoun, and I'll take successor. Maybe see if all three of
No,
us
sorry. My fault. Yeah, your mistake was including me. Sorry.
Yeah.
And Nick is lost.
That's because I'm not using Sublime. That's why. I started typing Sublime.
The problem is VS Code.
Yeah.
Yeah, that's why I put Vim in there.
All right. So this is looking pretty good.
Does it pass?
It passed.
Wow. What would she say if she saw us do it like this? Instead that one step at a time and checking every time. 3 at the same time very quickly.
So the thing with one step at a time is just to know how to do it when you have bigger refactorings. And let's say we do make this. Well, this is a relatively small change, right? But let's say it's a little bit more complicated, but we thought we could do it anyway. We thought we could just stick bottle number dot successor in there, and it all fails. So the thing is to know what to do when it fails. Would you start debugging right away? No, she says revert your change and make the small steps. So I think it's more of just knowing how to do it rather than consistently making those small steps.
I like it, yeah.
So that's it for this week. We will continue here. 5.2.4, removing arguments, which is going to, we could probably finish that real quick. We won't. Yeah. There's just something about, that's all right. We'll get to it next week. Yeah, so removing arguments. Yeah, it's a good session. I'll be sure to commit this and Let me status bottles. Yeah. Okay. File, modified file. Yep. Okay. Git commit, and this is what I'd say 5.2.4. Okay. What the hell did I do?
Nick, have to go. Thanks for the session as usual. See you
man.
next time.
All right. Sounds good.
Bye.
See ya. Thank you for joining.
All right.